Hello students, how are you all? I hope you all are fine. In the first class of relative motion, we came to know how to break down the concept of relative motion. But today, we are going to dive deeper into the concept of relative motion, and that way we will learn to predict the numerical and to apply it in our day-to-day real life. You wonder how? So, I am just going to let you know very simple tricks that will help you to make complex problems seem easy. And that way we are going to increase the speed of numerical solving like never before. Let us start today's session. I am Nitesh Sir. I am presenting before you the session of relative velocity. Let us start it today. So here we learnt about the concept of relative motion in the last class, and we learnt about few of the concepts like relative position, velocity and relative acceleration. So what we came to know? We came to know about relative position, velocity and acceleration. See, I have drawn one of the diagram here in which you will come to know that when one of the object is behind some another object and they both are moving all together, then what happens if the question is demanding you that to know when B object will be catching object A. So in that case, we can apply the concept of relative motion. You know how? So for that you must first of all check the basic lecture of relative motion, and it is already uploaded on our channel. So you must go there and you just watch it. You will come to know about all those concepts. But even though I am just going to recap all those concepts in a very faster way. So let us concentrate on this concept. Here you see, when B is moving this way and A is moving in this direction, so BA is written in this way and VB is going in this way. Now if the intention of B is to catch A, then we can do what? We can just apply the concept of equation of motion on A object and B object separately, and then after we can make the numerical little bit faster and it will be time consuming to solve the same question. So we are going to apply the concept of relative motion, and how we are going to do? So one of the object we need to just bring it on rest. How we will bring it in rest? So just we have to reverse the velocity of A. So to reverse the velocity of A, if I am just writing it here minus VA, what will happen when minus VA will be adding up with VA? Then it will bring this particular object into rest. You will say, sir, will it be the real case? No students, no friend. It is not like that. Why I am doing this? Just to make our math easier. Are you getting my point? So that way what happens, that we are just bringing this object into rest, and the same velocity by which we have brought this object into rest, that we are going to add up with the velocity of B. So here what happens, this is velocity of B and we are adding it here, this particular velocity. So this way we are adding it here, minus VA. So then in the next moment what happens, when we are going to add minus VA with VA, it will bring this particular object into rest, but this object will be moving ahead with VB minus VA, and this VB minus VA will be called as relative velocity. Are you getting my point? What we need to do is, you just need to reverse either of a velocity in a reverse order to make it into rest, and you have just to add it with the another velocity, so that we could be getting the relative velocity, and then we are going to approach the numerical. So that way what will happen, this object has come into rest, this is in rest, this is now moving with velocity of VA minus VB, and some distance is already given. So when we are going to take the concept of this particular segment, then the numerical will be becoming very easier to solve. How? The distance is already given, velocity is already known, and then if we have to find out the time, we can just find it out. Are you getting my point? So that is the concept which we are going to apply in position, velocity and acceleration. Always we are going to apply it on all these particular parameters. So that way we can say acceleration of A with respect to B will become acceleration of A minus acceleration of B. Mind it, you have to put the sign of acceleration in the way you are considering either right side as positive or left side as positive. Whatever you are considering, you just need to put the sign in this particular formula in the way you are just assuming it. For example, if this particular B is moving in this direction and A is moving in this direction, so they both are moving in the positive direction. I am considering right side to be positive. So BA and BB are both considering to be positive. So that way, if I am writing BA B, then we are going to write it like this: BA minus BB, and they both are considered to be in positive direction. So that way it happens to be like this: BA minus BB. Are you getting my point, students? That way again we are going to write acceleration of A with respect to B in the same way, and similarly we can write down position of A with respect to B, and that will be position of A minus position of B. And why I am writing this particular symbol along with the direction? Because we need to just consider the direction as well. So these are all the points which you need to just keep in your mind. Then after, once we are done with this concept, we have been gone with various examples so that you could be getting the idea of how to solve the numericals based on these concepts. Then comes relative motion in 1 and 2 dimension. 1 dimension is already done. Today we are going to discuss with 2 dimension. One more thing, in 1 dimension, acceleration due to gravity part was not covered. So today we are going to cover it also. And then after we will be coming up with this concept of relative projectile motion and shortest distance. And later in further lectures, reverse human problem also we are going to cover up. Got my point, students? So let us start this. In the next slide, I am moving up with the concept of relative motion under gravity. So students, what happened here? You just see. In the last class, I said you that acceleration of A with respect to B means what? Acceleration of A with respect to ground minus acceleration of B with respect to ground. Those students who are newcomer and those who are watching it, those who are watching lecture number 2 in a first time, so for them what I am telling you, you just consider this example. If suppose this is a train and some person is walking on this train like this, and he is walking with 2 meters per second, but this train is moving with 10 meters per second. I will be asking to you that, students, please let me know that what will be the velocity of this person with respect to ground. So few of you may tell that 2 meters per second is nothing but the velocity of person with respect to ground. But I deny. I will say you just assume yourself as a small ant and you are just sitting over here like this. Very animated kind of ant you are. You just see. So then what I mean to say is, if suppose you are watching this person from this frame, I am in the frame of train. So from the frame of train, if you are watching this person, you will observe that this person is moving with 2 meters per second. But when you are observing it from the ground, shall it be the same? Do you think will it be the same? No. Why? Because we know that and this person is moving with 2 meter per second and it is moving on the moving frame. So definitely it will share the velocity of this particular frame. And this is what you must know, that velocity will always be shared. But even though if I am just going to apply it with the concept of mathematics, what we are going to do? Velocity of person with respect to train will be equal to velocity of person with respect to ground minus velocity of train with respect to ground. If I am telling this 2 meter per second, so this 2 meter per second is with respect to train. Why? Because if we are observing by becoming the ant and sitting over this particular frame, then we will observe that this particular person is moving with 2 meter per second and in positive direction. So we are going to write it like this, 2 meter per second, and in positive direction, so plus 2 is equals to velocity of person with respect to ground. We don't know. We just want to know this particular value. And this is 10 meter per second, which means this is 10 meter per second. So what will be the value of velocity of person with respect to ground? So students, this will be nothing but 12 meter per second. I hope you have come to know how to understand which of the velocity is under which frame. Are you getting my point, students? If yes, then please give a very good dil wala shape emojis there in the comment box, so that we could be getting more and more motivated to give such a kind of concept to you guys. Now, if you have come to know about this concept, then you just come here. You just apply all these concepts, the same concept over the acceleration also. Why? Because we are going to learn about the relative motion and the gravity. So we are going to apply the same concept over acceleration as well. So acceleration of A with respect to B will be acceleration of A with respect to ground minus acceleration of B with respect to ground. Similarly, we are going to write this particular formula. So guys, you just observe this particular diagram and you just imagine if this person is dropping the ball, means u is equals to 0, and this person is throwing up the ball with u is equals to 10 meter per second, what do you think? What will happen? What will be the relative acceleration? Just let me know. What will be the relative acceleration? Yes, definitely it will be 0. Definitely it will be 0. Why? Because if this person is dropping this ball, so acceleration is minus g. And this person is just throwing up, also it is under the influence of minus g meter per second square. Right, students? So what happens when this particular object has been thrown up and this is dropping down? So what will happen, that if we are going to find out this as A and this is B, so if we are writing it acceleration of A with respect to B, then acceleration of A with respect to ground minus acceleration of B with respect to ground, and both are with negative sign, so we are going to write it like this, minus G minus of minus G, so it will become 0. So if acceleration becomes 0, you just let me know which kind of motion it is. When the acceleration will be 0, acceleration is absent, then definitely that kind of motion is called as constant velocity or uniform motion. Right, students? So that way, this two person means both of them are under the, if I am just going to apply the concept of relative motion, then they both are relatively in constant velocity condition. And so they both are just applying the concept of relative motion. If I am applying the concept of relative motion, then they both are moving in the straight line. This is a very simple format. You must know that if the acceleration is absent, then the motion will be a straight line. Definitely it will be a straight line. So definitely those concepts I am going to apply it here in the coming slides. Whenever there will be the numericals, we are going to apply this kind of concepts there. So you must just take the screenshot of this slide and let us move ahead. Fantastic. Guys, I hope you have taken the screenshot. Let us move ahead. Here. What is the see guys, what is the condition? We have come to know about relative velocity, we have come to know about relative acceleration. Now we are going to apply it in our numericals. So more of the examples we are going to see, more of the concept we are going to learn. So let us move ahead with more of the examples first, so that we could be gaining more of the learning out of these examples. Let us start here. Ball A is thrown downwards from the top of a building of height 40 meter with a velocity of 10 meter per second. This one is 10 meter per second. At the same time, another ball B is thrown upward. This particular B ball has been thrown upward with 30 meter per second from the base of the building. As shown, find the time and height of ball A from ground when the two balls collide. Okay. So this one, oh my god, what is the case? See guys, this one is 40 meter, this one is 40 meter. So what happens if I am talking about A? Find the time and height of ball A from the ground when the two balls will collide. So what we need to do, we are just going to make it in rest. So to make it in rest, we are going to just add it with 30 meter per second in negative direction, right? And same particular value we are just going to add it up here, 30 meter per second. So guys, what will happen? This VAB will become 40 meter per second, I hope. Guys, have you understood it? And this particular person will be coming under rest. Now, what will happen? If this person is moving with 40, so this object is moving with 40 meter per second, now we need to find out relative acceleration. I hope they both are under the influence of acceleration due to gravity. So acceleration of A with respect to ground minus acceleration of B with respect to ground will be written in this way: minus G J cap minus of minus G J cap. So it will become 0. So if the acceleration is 0, both of this particular object are relatively under uniform motion case. If they both are relatively under uniform motion condition and if acceleration is 0, so they both are moving in a straight line. If they both are moving in a straight line, you must know this, that now this person is having the intention of directly hitting this person and this person is at a height of 40 meter. So now when the acceleration will be 0 and relative velocity is given, relative velocity is minus 40 meter per second. So you must know this, that time is equals to distance upon velocity, right students? What is the distance from A to B? It is 40 meter. So here we are going to write it minus 40 meter and upon minus 40 meter per second. So this way it will be 1 second it will take to collide. It will take 1 second to collide. Guys, have you understood this? Very good. Very good. So if this person has been coming to collide with this B object, then it will take t is equals to 1 second to collide. Now the case comes that at how much height it will be done, the collision will be done. So in that case, what you need to do, now you directly come to the frame of A and you just understand this 10 meter per second wala thing and you just apply it here. S is equals to ut minus half of gt square, and how much time we have to consider? The time must be considered as 1 second. So that way we are going to apply it here. U will be minus 10 into 1 minus half into 10 into 1. It becomes how much? Minus 10 minus 5, it means minus 15 meter. So if I am talking about just the distance, if I am just talking about the distance, so it will be nothing but 15 meter, right students? So from top point, if it is coming up to 15 meter, so up to 15 meter it is going to get collided. So this 15 meter is how much distance from the ground? 40 minus 15, how much it is? 25 meter students. So that 25 meter will be considered as D is equals to 25 meter will be the height at which collision will be done. Are you getting my students? I hope you all are understanding and you all are getting these points. And if these concepts have been very much clear to you now, so please like the video and please make the heart emojis in the comment box. Okay. So that way we are now coming up with the more of the examples so that it will be very much clear to you guys. So you just take a screenshot of this particular slide first of all. Let us move to the next slide now. Here it is. See guys, two identical balls are shot upward one after another at an interval of 2 seconds along the same vertical line with same initial velocity of 40 meter per second. The height at which the balls collide is. Yes. What is the case? You just understand first of all the question. See guys, this is the floor. And what this question meant to say is, two identical balls are shot upward one after another at an interval of 2 seconds. So at an interval of 2 seconds they are telling. So you just understand that if suppose one of the object has been shot with 40 meter per second, another object is somewhat here. So what is the case? If this is t is equals to 0 second, this is the case of t is equals to 2 second guys. What is the actual condition? This is 40 meter per second and this particular velocity is nothing but Vy is equals to Uy minus Gt. I hope you all are understanding this point. What is the thing? Two identical balls. So this is ball B and this one is ball A guys. So what happens when after 2 seconds this particular ball A has been raised up to some particular height and with some velocity, and at that instant this was being getting projected with 40 meter per second. Are you understanding from this concept? You just understand the thing. One after another at an interval of 2 seconds guys, along the same vertical line with same initial velocity. So this has been heated up with 40 meter per second 2 seconds later to what the ball has been sorted up. Now what happened? That it was being sorted up with the 40 meter per second value and minus 10 into 2 seconds. So it becomes 20 meter per second guys. And at that instant this is being sorted up with 40 meter per second. Are you understanding my point? So that way what happens? We just need to find out the distance between these 2 points. How we are going to find it out? So we just find out the displacement being done by ball A. So let us see here. Sy is equals to 40 into 2 minus half of 10 into 2 square. What happens? This is 80 minus 5 into 4, 20. It becomes 60 meter guys. So here this particular distance is 60 meter, in which here it is 20 meter per second and this is 40 meter per second guys. So I told you one concept. What it was? You just need to reverse either of a velocity and you just need to add it up with the another velocity and then you have to apply the concept. If both are with the same, if both are under the influence of same acceleration, then relative acceleration will be 0 and in that case the motion will be in a straight line and it will be under the influence of uniform motion. Alright, so that way we are going to apply it here. Ball A is under the influence of guys motion under gravity. Ball B is under the influence of guys motion under gravity. So relative acceleration will become 0 sir. And if this is relative acceleration and it becomes 0, so you just understand the thing that if the relative acceleration is 0 and relative velocity it is having some value like this. This is 20 meter per second in upward direction. What we need to do is we need to just reverse this in this way, 20 here and 20 here. So once we are going to reverse it out, the net velocity will be in upward direction with the value of, you tell me, it will be 20 meter per second. This becomes rest. Guys, you are understanding this? This will be cancelling out. Sorry. This and this velocity are going to get cancelled, so this will be coming under rest. This is 40 meter per second, this is 20 meter per second. So net velocity will become 20 meter per second in upward direction. And if it is in rest, this is moving with 20 meter per second. Relative acceleration is 0. Distance is given. So can we find out the time? Yes. How we are going to find out? Time is equals to distance upon v relative. So guys, what is the distance? 60 meter, and relative velocity is how much? 20. So it becomes 3 seconds. 3 seconds is the time when they both are going to get collide. Now it is the homework to find out the height at which the balls collide. So you just need to find out what will be the height. Can you please find out the value of height? I hope you can. I am just giving you 2-minute time. You just apply your concept and find out the height. Yes. So what happens, guys, that you have understood that it will be colliding after 33 seconds. So then we are going to apply 3-second time to either of this particular object. So let us apply it on object B. So I am telling that h is equals to 40 into 3 minus half of 10 into 3 square, 5, and this one is 9 into 5, 45. This is 120 minus 45, so it becomes 75 meter, I think so. Yes, so this is 75 meter. 75 meter is the height at which they both are going to collide. I hope you all are understanding my point. So this way we are going to solve the numericals with the help of relative velocity. Kindly take the screenshot and let us move to the next slide. So guys, this is one of the question. A ball is dropped from a building of height 45 meter. Simultaneously, another ball is thrown up with a speed of 40 meter per second. Calculate the relative speed of the balls as a function of time. What happens, guys? I am not going to just solve this question. I am just going to narrate this question so that you are going to apply your concept and you are going to solve the question here accordingly. So guys, what I mean to say is, if suppose this one is the building and they are saying a ball is dropped from a building of height 45 meter. So the height is 45 meter, guys. The height is 45 meter. One of the object has been dropped, u is equals to 0, and simultaneously another ball is thrown up with the speed of 40 meter per second. So another ball has been thrown up with the velocity of 40 meter per second. Guys, I hope you could have understood what they mean to say. Calculate the relative speed of the velocity as a function of time. See guys, at some time t, at some time t. If I am asking you, then please let me know what will be the velocity of this u is equals to 0 wala object. So v will be equals to u plus at. Guys, you could have understood how this equation is coming now. So if I am talking about y direction and y direction, so Vy will become 0 minus 10 into t. Alright guys, so Vy is nothing but minus 10t. This Vy is of this particular object. Now for this object if I am talking, then Vy will be equal to 40 minus 10 into t. Yes, I think you all are understanding my point. So at some time t, this is having the velocity minus 10t, this is having the velocity 40 minus 10t. Let us consider this as the velocity of b and this as the velocity of a. If we are going to find out the relative velocity, then velocity of a with respect to b will be velocity of a in y direction minus velocity of b in y direction. So that way we are just going to apply the concept and we will be finding out the value of relative motion as a function of time. I hope you could have understood this numerical. You just apply this like minus 10t minus of 40 plus 10t. This is now velocity of a with respect to b as a function of time, and exact value will be nothing but 40 meter per second. I hope you all are getting my point. So that way we are going to apply the concept here. One very favorite question, basis of two stones are thrown up simultaneously from the edge of a cliff 240 meter high with initial speed of 10 meter per second and 40 meter per second respectively. Which of the following graph best represents the time variation of relative position of the second stone with respect to the first? I hope you could be understanding this particular question, and I am expecting that you guys are going to solve this question. Am I right or wrong? I am 100% right. Please try this question and I am coming back. So friends, I am back now. Let us start this question. Here this is a building, and if I am telling this is a floor, two stones are thrown up simultaneously from the edge of a cliff. Sorry, this is a cliff 240 meter high. So guys, here it is 240 meter high. This one is 240 meter high. So what happens guys, that one is moving with 10 meter per second and another one with, this one is have been thrown up with 10 meter per second, another one has been thrown up with 40 meter per second. So guys, definitely you could have understood that 10 meter per second object will be getting dropped prior to the 4 meter per second stone. Are you getting my point? So that way what happened, that if suppose that 10 meter per second has been dropped out, so let us know what will be the time it will be taking. So if suppose I am telling that minus 240, one second, s is equals to ut plus half at square, we all know. So minus 240 meter is equals to 10t minus half into 10 into t square, students. So what will be here then? 5t square minus 10t minus 240 is equals to 0. So that way what will be the condition? T square minus 2t minus 448 is equals to 0. Is this clear, guys? So now you need to split up. T is equals to 8 seconds. So what happens, friends, that 10 meter per second will fall down after t is equals to 8 seconds. So t is equals to 8 seconds, what will be the condition? This is 10 meter per second, so reverse it and add it with 40 meter per second, because both are under the influence of acceleration due to gravity, friends. So they both are going to move relatively in a straight line. So this 10, if I am just reversing it, and I am going to add it up with 40 meter per second, so it will become 30. Are you getting my point? So P is equals to y relative will be equal to v relative into time. Y relative will be equal to v relative into time. So what will happen? That till 8 seconds, the condition is y relative is equals to v relative into t, and so it will be a straight line. So till 8 seconds there will be the straight line. Here it is a straight line, here it is a straight line, here it is a straight line, and here it is a straight line. So understand this. So till this, all these graphs are having the common condition. Now what will happen after t is equals to 8 seconds? When t will be greater than 8 seconds, t will be greater than 8 seconds, then what will happen? Then understand the thing. T h will be equals to, when we are going to understand the concept of t is equals to 8 seconds and more than t is equals to 8 seconds, then what will happen? What is the difference between them? Till t is equals to 8 seconds, they both are in air, and after 8 seconds, one is on the ground and another one is on the air. So one has already taken the displacement of 240 meter. So the concept will be what? That y2 minus y1 will be equal to what? 240 is already taken by y2, means one of the object is already taken 240 displacement, minus ut 40t minus half of gt square. So students, do you understand the concept that y2 minus y1 is directly proportional to the square of time? It means the graph of y with time will be parabolic. Guys, you are understanding this? And hence, since the power of t is 2, so definitely this is a straight line. After 8 seconds, this is a straight line. This cannot be the graph. After, and this is 12 seconds, so definitely it is completely wrong. This one is hyperbolic, so this is wrong. This graph is correct. So this particular C option will be the correct option for this particular question. I hope you all have got my point, and if you are having any of the problem and you are facing any of the issues with this particular numerical, you may just drop down your feeling in the comment box, so that we could be coming up with the re-explanation part of this question. I hope you all have understood my concept of relative motion under gravity. So students, please stay tuned with us, and we are going to come up with more of this kind of videos in the near future. Thank you very much. Namaste.